Okay, we're carrying on at 6.7. We're looking at an example now. Example 6.8, crash test. Okay, so we've got two collisions are carried out to crash test a 1,000-kilogram car. Okay. So number A, point A, question A, while moving at 15 miles per hour, the car strikes an identical car at rest. Okay. And the question, and part B is, I guess these are not questions, it's just part A and a part B. While moving at 15 miles per hour, the car strikes an identical car moving toward it, also traveling at 15 miles per hour. So we've got two identical cars in part A. This guy is moving and this guy is stationary. In part B, they're both moving at the same velocity toward each other. The question is, for each collision, how much kinetic energy can be converted to internal energy? Okay, let's just consider that. How much kinetic energy can be converted to internal energy? Okay, so if you just use that formula, which obviously you can do that. Okay, the formula is this: K convertible is half m1 m2 over m1 plus m2 times the relative velocity squared. You can use this guy, and of course this example, as you'll see, it does use this, but I would prefer, just from the beginning, you would rather try this. You would say, well, let's go from first principles. My system kinetic energy is the kinetic energy of my center of mass, non-convertible, plus the kinetic energy of all the objects in the zero momentum reference frame, which is the convertible. So all I need is K system minus K of the center of mass should give me my K convertible. So what is the system kinetic energy for A? I'm not going to, you see it's in miles per hour here. I'm not going to convert it for you, but here you convert it into meters per second. So for A, you would have half m1 v1 squared plus half m2 v2 squared. That is my system kinetic energy. It's the kinetic energy of both objects minus the system kinetic energy, the kinetic energy of the center of mass, okay, which is half m1 plus m2, that's the total mass of the system, times the velocity of the center of mass squared, equals K convertible. All right? So this is exactly the same. So what is this? Let's half times 1,000 times, what's the velocity of 1? 6.7 squared, plus what's the velocity of this? It's 0. So our system kinetic energy in the Earth reference frame, I must say this, in the Earth reference frame is this. That's the total system kinetic energy in the Earth reference frame. But now we need to subtract this guy, which is the kinetic energy of the center of mass. So we know what the inertia 1 and inertia 2 is, so that's half, and that's 1,000 plus 1,000, so that's 2,000. But now what is the velocity of the center of mass? What is that? The velocity of the center of mass is the velocity of the zero momentum reference frame. And how do we calculate that? Well, remember, the velocity of the zero momentum reference frame, or the center of mass, is simply equal to the total momentum, the sum of the momenta, divided by the sum of the inertia. And what is the momentum in over here? It is m mass times or inertia times velocity plus inertia times velocity. And we know that the velocity of this is 0, so this is going to be m1 v1 divided by m1 plus m2. So m1 is 1,000 times 6.7 divided by 2,000, and the answer there is, now guys, I know you're saying this is the long way, but please try it this way so that you know you've got two directions of solving this problem. You know it from first principles, and then you also know it from this formula. Okay? So the velocity of the center of mass is 3.35 meters per second. As this object is as this car is approaching this car, there is a center of mass traveling at this velocity in that direction. Okay? And so we calculate the kinetic energies of these guys, and we subtract the kinetic energy of the center of mass. So this is then 3.35 squared equals my convertible kinetic energy. Okay? And if you calculate that, you should get, I got 11.22 kilojoules, okay, is my convertible kinetic energy. If you use this formula, now let's just look quickly. If you use this formula, this is easy. You got m1, m2, and m1 plus m2, but you need to calculate the relative velocity, and the relative velocity is v12, so it's the velocity of 2 minus the velocity of 1, okay? So what is that? It is 6.7. So you plug this in and you're going to get 11 kilojoules if you use this formula, okay? Now, this is taking a long time, but I hope this is helping you. I really hope this is helping you. I really want to help you guys, okay? Now, what is the fraction of this convertible? The second question is, what fraction of the initial kinetic energy of the two-car system does this? What fraction of the total energy, the kinetic energy of the system, is this convertible kinetic energy? So, how are we going to do this? Well, this total kinetic energy of the system is given by this, right? And what is this equal to? They say it's equal to 22 kilojoules. 22 kilojoules. So the convertible kinetic energy is 11. I'm going to use their values, kilojoules divided by 22 kilojoules. So it is 0.5. So the fraction of convertible energy in this case is 0.5. Okay? So now let's look at the second. How about in the next video we'll look at the second one, okay? See you next one.